Good afternoon, everyone. I welcome you all for the second day of International Winter School on Cybersecurity. So today we have with us Mr. Saisantosh Vernekar. He completed his undergraduation from KLS GIT Belgavi in the year 2011. Currently, is working as a senior information security engineer at Coles San Jose. He has total 9+ years of experience in the area of web application security, performing security assessment for web application and web services. He has worked with clients in various domains like retail, insurance, banking, telecom, etc. His key skills are core Java, J2EE application development, web application security. So with this brief introduction, I present before you all Mr. Saisantosh Vernekar. Over to you, Saisantosh.
Okay, thank you, Prashant, for the intro. So I just shared my screen, right? So
Yes,
thank
yes.
you. Yeah, I just wanted to thank you, Kajendra sir, and Padma ma'am, and KLSGIT for inviting me to speak here. So I'm just going to get started, right? So as like our world is filled with memes, right? So why not here? So this is the iconic scene from The War wherein Amitabh Bachchan says, right, the iconic dialogue. But today I'm using it here to say that आज मेरे पास IDS है, IPS है, firewall है, right? So IDS is intrusion detection system, IPS is intrusion prevention system, firewall, right? So these are some of the technologies that help you prevent cyber attacks, right? So here he says that भाई तुम्हारा cloud access key password public GitHub पे पड़ा है, means that the cloud access key or password, which is sensitive data, is out there in public GitHub. So with this, right, today there are multiple factors that one organization needs to consider to secure its infrastructure and web applications to protect its customer data from the bad actors, right? So with this, today I'll be talking about OWASP Top 10. And I chose this topic because this is a very good topic to get started with. So some of you might have heard about this, and some might be very new to this, but this is a really great starting point for anyone who wants to get into cybersecurity, or somebody who will be a developer, right? So even they can incorporate some of the standards that we'll be talking today. So, but before we start with that, what is OWASP, right? Like before OWASP Top 10, what is OWASP? So OWASP is Open Web Application Security Project. So this is a community-driven non-profit foundation which is dedicated to improving the security of software, right? So this community-driven foundation, right, that produces freely available articles, methodologies, documentation tools, right, to help the community and anyone out there to secure their infrastructure or web applications. But this predominantly deals with web applications. They also have mobile application as well, which they work on and provide insights to from a security standpoint. So let me move on to what is OWASP Top 10, right? So OWASP Top 10 is an awareness document of top 10 most critical application risks that are out there in the world today. So this is not typically a standard, like, top 10 critical things to be looking out for, but this is more of top 10 risks that are out there that one would need to take care of or be aware of, right? And they put this together by data driven and surveys that they conduct with various vendors and popular organizations out there, right? So they collect this and put together. So this happens every few years, right? So 3 or 4 years, right? So they release the new version of it. So the first time it released was 2003, and most recently it was released in 2021. Okay, so let's move on to OWASP Top 10. Okay, so this is OWASP Top 10 2021, which includes broken access control, cryptographic failures, injections, insecure design, security misconfigurations, vulnerable and outdated components, identification and authentication failures, software and data integrity failures, security logging and monitoring failures, and last, server side request forgery. So we'll go through this one by one, and if time permits, right, I'll be taking few examples to explain in detail. uh, so let's start, but before we start that, we'll just look at what was before 2021, right? So if you look at the left side here, 2017, so we have different categories, but here the names have changed, some names have changed, and there are three new categories that have been added. Okay, so if you see injection, so this started from 2023, very first year of OWASP Top 10, right? This was at the top, and until 2021, it was the topper, right? It had never come down from position 1, but this year they have put it down to 3. But still, it's an important vulnerability out there. And if you see external entity injection, right? So this was a category in itself or vulnerability, but it has been merged to something called as security misconfigurations. So security misconfiguration was the last year as well, but XXE is mixed or encompassed into the security misconfiguration. So likewise, cross-site scripting is included as part of injection this year, and insecure deserialization is also merged with integrity failures. So we'll take one by one and look at how and what these issues are. So the first one is broken access control, right? So broken access control is nothing but authorization. Okay, so it's like, say, everybody at college has ID card, including staff, professors, students, right? And with the ID card, they're allowed inside the gate. So that is authentication. But once you get in, right, what you can access class A, class B. That's the authorization for that particular person. But class A, class B, but also they can enter staff quarters, right? So that is additional authorization they require, right? So that is authorization. What you can do or where you can go, what data you can access is authorization. So access control enforces policy such that users cannot act outside of their intended permission. Okay, so failures typically lead to unauthorized information disclosure, modification, or destruction of all data, or performing a business function outside the user's limit. Like for instance, there is a portal for employees and managers and senior managers, right? So there will be certain functionality that only the employees can access, but managers can also see a particular functionality which lists employees under him. Similarly, for this senior manager, so different authorized roles, right? So when does a broken access control happen, right? So there are a couple of things that will happen, and we'll talk about it. So as you can see on screen, right, there are a couple of things. Violation of least privilege principle, right? So what it means is least privilege, where you should provide least privilege where access should only be granted for particular capabilities, roles, or users, but it is available to anyone, right? So meaning that by default, only publicly accessible pages of a website should be accessible to everyone and not the private ones. Okay, so similarly, there is something called as IDOR, insecure direct object reference. So meaning that, let's say I have an account and in the URL my account number is 123, right? So after logging in, I change that to 234. If 234 belongs to some other person, and if I'm getting the data, right, so it is called as insecure direct object reference. There is no check that that particular account belongs to the logged in user, right? So similarly, we'll take an example of this, of each of this, like, okay. And there's something called as forced browsing. So forced browsing is simply like if there is an admin page and you as a logged in normal user just visit that slash admin, and there is no proper access control that is implemented, due to which you also access the admin page. So similarly, the access control needs to be applied to the HTTP methods. So typically, right, we use get and post, right? But put, delete, right? All these methods also should be taken into consider when you have an access control policy. Because if you only implement it on get, the bad actor might try using other methods and try to access the data. So similarly, privilege escalation is, for instance, there are two types: horizontal privilege escalation and vertical. So horizontally is morely on the same role permissions, but vertical privilege escalation would be for a higher privileged role. So similarly, like there are multiple ways one provides authorization. So one of them is also JWT, and if the JW is not implemented properly, and one can rewrite and manipulate that to gain a probably a higher privilege. So there is something also called as CORS. Okay, so cross origin resource sharing. Uh, so and if you misconfigure that, right, so that can lead to broken access control as well. So a browser by default implements a policy called a same origin policy. What it means is that if there is a site xyz.com, right, and on the other tab there is abc.com, any script or any code from abc.com cannot access anything from xyz.com. But like that is very strict control, and today's application also want to talk or try to fetch data from their own domains, but it's not exactly xyz.com, maybe a subdomain of xyz.com, right? So that is why CORS is in place, wherein you tell that you allow that particular endpoint to access, but if it is misconfigured, anyone can access the data. So like I said earlier, right, so if there is a particular web server and a web application, so bad actor, like he has a code of 126, other user has 123, right? And if there is no check that when a request comes through, instead of asking for 126, if they ask for 123, this is just a simple example of insecure direct object reference. So all the data belonging to user here will be given to the bad actor. So now this is very manual and looks very, like, cumbersome, but with automation, right? So it's very easy to code this and enumerate all this IDs and get all the data. So let's take another example. I mean, it's the same example, but looking at the code, right? What they could have done is that this is a SQL query wherein, and this is the example where account number would be here. So once it reaches the server, the account parameter value will be coming here from the request.get parameter. And you see here directly it is being used as part of the SQL query prepared statements. And there is no validation if this particular account number belongs to the logged in user. There is no record check, right, that it belongs to the logged in user. So with that, right, such access control issues can happen. So the second thing is, like I said, forced browsing, right? So instead of get app info, so there are and you might ask, like, how can one identify all these endpoints, right? So these are very common, and there are specific tools like directory busters and tools which will enumerate with word lists. And if there are any hidden endpoints, right, and they do not have access control properly implemented, they'll be able to get that particular endpoint. So similarly here, right, for a post body, so if there is a group ID, right, so say, let's say group 1 is for employees and group 2 is for managers, right? So if they have placed any order, right, or anything, like, like in a software world, right, you can place some things. So if anybody is changing this, and if they are able to get the data of other group, right, so that is a broken access control. There is no proper implementation of broken access control. So this is another example wherein, directory traversal is possible, meaning that, let's say this is a file name, right, but there is no validation on the server side, and you can just, let's say the Linux server is Linux, so you can use .. and try to access the system file, which would even, and if it works, it will give you all the data of that particular file. So let me just show you an example where, right, so this is a dummy application where I have hosted, and this has something called as directory listing, right? When a server is installed, by default, if it's not turned off, right? So it's an issue. So if you see here, if I remove this part, right, so I can see all the folders and structure. So similarly, there are other folders that you can access. And if you see here, all sensitive data, if it is placed there, it is accessible. So it's a bad practice to do, and you need to disable the directed traversal. So prevention method for this would be deny by default, meaning that only public information should be available. Any private data for any user should not be available out there. Okay. Then you have to implement access control mechanism once and reuse them. So meaning if you have a centralized access control, right? So it would be great, and any form of features that you implement, like new features, that should go via that centralized access control. So similarly, enforce record ownership, meaning that if any particular data is requested, you need to check who is the owner for that. Is the user who is logged in, or who is requesting it, right? So depending on that, you show the data. So also disable directory listing, what we just saw. Also log access control failures. Like if there are 100 items for particular username, right? That means somebody is trying to get in there, right? So if you have ever tried to reset your password in Gmail or anything, right? So you'll get an email, somebody is trying to log in from a different computer. Is that you? That's something like that. Also rate limit API. Rate limiting is nothing but putting some kind of bot protection, bot manager, wherein automated attacks can be blocked. Uh, Also, once a user logs out, right, it is good to invalidate that session, right? So if a password is changed, right, so that time also you should probably change the password. So that is broken access control. So we'll move on to the next one, which is cryptographic failures. So cryptographic failure, right? So the first thing here is to determine the protection needs of a application for the data that they handle. So it might be in transit and at rest. For example, if the application is handling passwords, credit card numbers, health records, personal information, or probably business specific proprietary data, right? So you also should consider different laws that are available, like GDPR, which is the General Data Protection Regulation, or PCI data security standards, right? So some of the questions when you handle such data, right, are, I mean, you have to categorize the data first and then ask some of this question, like, is the data transmitted in clear text? This is specifically when data transfer happens. So is it secure, not just from client to the server, but internal server to server calls as well should be checked. Also, are you using any old weak cryptographic algorithms or protocols? Are you using any default or weak crypto keys, right? So try to see if the keys that are being used are default ones or weak ones. Also, you need to have a proper key management system, and you have to see things like the sensitive data like passwords, keys are not hard coded into the code and are actually being maintained via a key management tool like Vault. I'll come to that. Also, make sure that you're not using MD5 or hash SHA-1. These hashing functions are outdated and are known to prone attacks. So one of the popular data breach happened was Marriott data breach, wherein I think all the details of the customers were exposed, and some of them were not, protected. So a bad actor can get access, maybe due to some other vulnerabilities. That is one thing, but the data should be protected either by encrypting or hashing, like password or anything, or tokenizing the credit card numbers, right? So all this PCI, PII data needs to be protected. So that's the second layer of protection. So even if the data was stolen, somebody shouldn't be able to use it, right? So in this case, it was very bad, and all the data was available. Uh, so yeah, so so this is again same what we discussed, enforcing TLS, which means that data in transit should be protected, right, from browser to the server. So but if you are using TLS but also you are using weak cipher suits, right? So when certificates talk to each other, they use some of the cipher suits, and there are many cipher suits which are which are prone to attacks. And also you should make sure that the entire site is HTTPS. Like only some endpoints are HTTP and some points are HTTPS, then there is a possibility that one can perform downgrade attacks. So downgrade attacks are nothing but, let's say you are in a public cafe and you're trying to access xyz.com, and if the public router was compromised, right, so man in the middle attack is possible, but if the site is HTTPS, it is still protected. But if it is not HTTP, yes, then the attacker can sniff the network and see all the traffic that is going through that particular compromised router. So similarly, if you are, like I said, right, if you are storing sensitive data in your database, you should kind of use all this strong graphic algorithms, hashing methods. And when you're hashing, you should use something called as hash, which makes it more difficult for anyone to break it without using salt, right? Even if you find hashed passwords, what happens is there is something called as rainbow tables, and rainbow table is nothing but pre-compiled hash of known passwords, and they compare against it and try to break the hashed password that is being available at any of the breaches. So how can one prevent all this, right? So classify the data, what kind of data you have, identify the sensitive data and what laws under they fall. So encrypt data at rest and in transit. Okay, so you use the most up-to-date encryption techniques, and a very important thing, thumb rule that one needs to follow is not to reinvent the wheel of encryption, right? So many have tried and failed, but it's a good practice to use the known encryption techniques. So another thing is disable caching for sensitive data, where like for example SSN, PII data, PCI data that one collects, right? So caching is browser cache will have it. If you're using public computer, right, so that cache will still be there. So if any other person comes there, it'll all be accessible there. So, and do not use legacy protocols like FTP, SMTP, right? So these are all not secure because there is no encryption. They are like HTTP. Okay, use more secure like SFTP, SMTPS to transport any form of sensitive data. Also, when storing passwords, there are very known hashing functions like, argon2, scrypt, bcrypt, and pbkdf2. So what's special about these is that there is a delay factor. Okay, so there are other known algorithms like SHA 5tel 256, right? But these are known to have a delay factor which makes breaking them if compromised, right? So if password hashes are compromised and if any of these are being used, so it becomes more difficult to break them. So another thing is, like I said earlier, do not hardcore your passwords or service account keys, right? Certain things. So you need to use a vault or a key management service. Like the popular ones are AWS Key Management Service, HashiCorp Vault, Azure Key Vault, and every time you need, you fetch it from there. So and last but not the least, do not store any sensitive data unnecessarily, right? If you do not need, just keep it in memory and destroy it as soon as possible. So because data that is not returned cannot be stolen. So that was cryptographic failures, and now we move on to injection vulnerabilities. So you might have heard injection vulnerabilities, right? So like I said, this was top 1 and now it is moved to top 3. So what is injection vulnerability? Injection is a broader category and it can be form of any, like SQL injection, OGNL, LDAP, right? And another thing here to see is that XSS cross-site scripting is also part of injection now. Okay. Okay. So application is vulnerable to injection attack when user supply data is not validated, filtered, or sanitized by the application, or dynamic queries are used, or non-parameterized calls without validating the input. Also, hostile data is used within the ORM parameters to search sensitive records. Also, there is another way, like hostile data is directly concatenated to this queries. So this is mostly around all different type of databases, or even OS, like command injection is possible. Okay, so some of the popular injections are SQL, NoSQL, OS command, or ORM, LDAP, right? Or expression language, OGN. So we'll take one example, but it will be same for others. The concept is going to be same for others, but only probably the syntax will be different. For example, if you are targeting a LDAP, right? A lightweight directory access protocol. So you need to use that particular syntax to find the injection vulnerability. So we'll take SQL injections wherein attacker sends data containing SQL fragments to the database, I mean the code, the web server, which processes, and then the manipulated query will fetch the data and send it back to the user. So let's take an example where email and password is being sent, and this is the piece of code that is going to process it. Okay, so this is a SQL query which is being processed. So now let's say the supply data value is abc at xyz.com. This is just a dummy, right? And instead of password, right, ideally one would enter their password. So instead of password, the bad actor provides a string like this. Now what it does is that, okay, so this is how it will look when this will be, the variables will be placed with actual values. And if you look now, right, select star from users where email is equal to this, okay, and password is equal to MD5 hash of this. And now the statement has actually changed. There is a or condition now, right? And the condition says 1 equal to 1. And this hyphen hyphen says that exclude anything after this. So this part will be excluded. So essentially, this is how it will happen. So this becomes false, right? These both become false. There is no email like this and there is no password like this. So it's false. But the whole query changed. The SQL statement changed because of this particular input. Okay. And if you see now, the entire statement becomes true. So select star from will fetch all the data from that particular database, that is database. The point here to understand is that direct user supplied input was being processed dynamically. Okay. So that was the root cause for this. So I hope you understood that dynamically processing the user input is dangerous, right? So how can one prevent this? Like, the main important part here is to keep data separate from the command and queries, meaning that, so you do not process the entire statement dynamically with the user supply data. So separate this. So maybe you should use compile the code first and then at runtime supply the data to that. So that way a error will be generated, and as the code would have already been executed, this wouldn't happen. So also, if possible, use safe APIs, right? So safe APIs will try to make sure that, I mean, the preferred option is to use a safe API which avoids using interpreter entirely, or provides a parameterized interface, or also migrates to ORM mapping tools, right? Object mapping tools. So another thing that one could do is use server-side input validation, of the user supplied data. So now if you, but this becomes little difficult because when you have a allow list, right, that special characters are not allowed, most of the applications would need some kind of special characters. So this is not a complete defense here. So one would need to use probably parameterized queries to make sure that the code is separated and the data is separated. Also use escaping characters. Let's say the user input contains some special characters, right? There is a possibility you can escape those characters with certain syntax for that particular language. Also, you can use limit option when you are trying to write a query. What this will do is this will make sure that the data that is fetched is limited to certain rows and the entire data is not compromised. So that was injection, and we move on to insecure design. So what is insecure design? So this is a new category that has been added as part of OWASP Top 10. So as the picture here depicts, right? So it's very important you design way ahead, right? So there is a very difference between the design and implementation. Insecure design is a broad category, right, representing different weaknesses for a particular application. So there is a difference between the insecure design and insecure implementation. So a secure design can still have implementation defects leading to vulnerabilities, right, that can be exploited. But insecure design cannot be fixed by a perfect implementation. So just let's go through some of the things, some of the examples of how insecure design will look like, right? So when you, there is a concept called as shifting left in security, right? Shifting left means for a project or an application development, right, there is a planning phase, design phase, development phase, unit testing, then QA testing, performance testing, security, and then deployment. But we want to make sure that security is not coming last, and we want to move left, that is trying to move towards left and trying to make sure we are included as part of development life cycle. So it's like, every time you find a critical vulnerability during release, so it becomes a pain for the developers, the project management to go back and rewrite piece of code. It's not cost effective. It is also it increases the cost of the development project. So some of the examples here, or I would say insecure design, would be like, right, for example, you are building the application, there is a login page, right? So you thought about login, you thought about the features, but you also need to think about how one would abuse this application, misuse this application, right? Somebody's trying to log in, right? So you should make sure that there is logging happening for failed login attempts, right? Or let's say there is a application which uses only user ID, so that's a bad thing. If you see some of the results that are announced, right, only uses the roll numbers, so that's a bad thing. There should be some other parameter that one considers, right? So similarly, how is the password stored in database? Is it clear text? Or how is the communication happening? Is there TLS enabled? Do they plan as part of the design? Are they encrypting sensitive data at rest? So also how the application is running. Again, the least privilege by principle comes here. So application, how is the application running? Is the application running as root, right? So all these things are some of the things that one would need to consider from a security standpoint during the design phase. And when we consider all this during design phase, it becomes easier for one, right? Even for the team. So let's, to give you an analogy, it's like, let's say there is a building which is 80% built, and then someone comes and says that, hey, you know what, the foundation is not cool, and there is a possibility that the building might tilt, right? So it's very bad. You have to go and redo some work or do some patchwork, add some more pillars, right? Or if it is not working, then definitely you have to rebuild it. So that's why design becomes very important. And in today's world, most of the organizations are inculcating this habit to do architecture reviews, secure architecture reviews, and everything. So this is a similar example that we saw earlier, right? But from a different view, we are looking, wherein a bad actor, right? There is an account ID. Let's say Alice is trying to access bank, and similarly, Darth, who's a bad actor here, right? So there is account ID which has 4 digits. There is a pin which has 4 digits, right? So some of the design principles, if a AppSec guy was involved, right, they would consider to see, make sure that, hey, the account ID is easily guessable. You need to have a maybe alphanumeric character here, right? Make it more difficult to identify account ID. If you're trying to use a pin, make it more stronger, like, or set a password to access this. And how is the communication happening here, right? So that a bad design would give a bad actor easy way to access the bank and other users data. So it wouldn't, so if you see here, right, so the only combination is like, I would say 10,000 from 000 to 99991, and it is very easy to brute force all this using proper tools. And there are many tools out there which are also free. There are also commercial tools available to perform such intruder attacks. So with insecure design, right, there are a couple of things one can do to prevent all this. Inculcate the habit of secure development lifecycle. So definitely in an organization, there will be a cybersecurity team. Involve them starting from the planning and design phase, right? So when you tell them this is a feature that we plan to develop, right, explain them the architecture, they go back and they think and brainstorm and come back with certain recommendations like we saw earlier, right? So here, right, all this, some of the things that we talked. So create and use probably a secure set of design patterns, right? So say for authentication, you need to have some sort of patterns for that particular organization that the security team might have, right? So depending on your application, you will have options to implement maybe a authentication token or HMAC token. So these are some of the ways one can authenticate. Similarly, having a centralized authorization or access control mechanism, right, will help easily to inculcate that as part of the design phase. Also, the culture needs to change wherein there are only user stories written for features, right? So the security language and controls, right, that should also be used in those stories, saying that authentication needs to be enabled and specific details like what kind of authentication are we are looking at. Also, another thing that the AppSec professionals that you involve will do is they'll try to come up with misuse cases or abuse of functionality, right? So let's say there is a pizza portal and you get like 80% off when you have a coupon, right? So if that coupon every time you use, right, is very predictable, right, one can easily crack that how it is generated and write a piece of code. So there was a point in India Domino's, right? This happened back. One guy had actually put up a site where he had put a script which would generate coupon and almost 80% off, I believe. So there's such prediction, misuse of certain features, right? The feature, depending on the feature, the abuse case will come up. And also performing threat modeling is one of the popular way to inculcate in the design phase. So when you have architecture, there is security review that happens, and the threat modeling process is like identifying the assets, meaning the organization assets like server, web server, or any other cache that you are using, buffer, Kafka, like queue, messaging queue, like all these architecture assets, right? So then they have an overview, then they decompose the application and identify the threats, right? When we say decomposing the application means assets, then who are the users, right? How can they be threats? A threat, insider threat is also a threat. Insider threat meaning that an employee can try to push in a malicious code, right? How do you protect that? Or a bad actor can try to brute force certain things. How can you identify that? With that, document all these threats and rate these threats. And there is a certain models tried, it's called a stride as part of threat modeling. You can implement that and try to prioritize what needs to be fixed first, right? So inculcating this becomes very important at a very beginning. That way, there are no surprises when the code is being pushed or deployed to the production. So with that, we move on to the next topic, which is security misconfiguration. So yeah, so security misconfiguration, right? So if your application is vulnerable, if there is no hardening followed, or say all the components that are enabled, right, along with that there are unnecessary features that are enabled or installed, or probably unnecessary ports services are installed on the server. um, and it's very easy to find out what ports are open for a server or what services are running. Let's say there is a server which has Apache that is installed, or MySQL, MongoDB, and all other services are installed on that, right? So if I have the IP address for that, right, I can run a tool called as nmap, and it will give you a list of open ports. And along with that, you can also run a scan on those ports to see what services is running. And that's a different topic, and it's pen testing field. So but just to give you an example, right, if you find a service like a MongoDB, right, and it has default passwords enabled on it, so it's a misconfiguration. Or weak password is used, that's a misconfiguration, because it can be brute forced with common password word list. So another thing that you commonly see is poor error handling. Like the error handling is so bad that it reveals the sensitive data, like SQL queries that the internal code is using. And one try, like, by fuzzing. Fuzzing is a technique when you send unexpected data to the application and try to generate an error, right? In this course, you try to invoke such kind of error that it will reveal some data, and you can then plan your next steps as a bad actor. So some of the security features are disabled. Like for example, some of the kiosks, right, they use browsers by default, right? And browser by default comes with some security settings, right? So that will be disabled, right? And then you are security misconfigured. So similarly, there are various different frameworks that we use today, right? Like Spring Boot, right? Uh, so by default, these frameworks come and they are open to certain endpoints. Okay. And like any third party vendor that you, or a product that you, off the shelf product that you install, or library, default configuration needs to be taken care. Some of the examples are again, like, directory listing. So if it is not disabled, one can easily look at the directory by just traversing through the directories. uh, let's say Apache is installed, right, the default admin access is available, and if there is default username password, that's a bad configuration. Similarly, the stack trace that we were talking earlier, right? So if you see here, so all the query that is being used, or particular ID, right? So certain, depending on the application that is being built, such errors should be graciously handled. So like I was talking right earlier, the frameworks, like a popular framework is Spring Boot. Okay. So Spring Boot has something called as activator, and this is used to get certain information about the running application. Like if you see here, the endpoints, activator slash audit events, beans, health, conditions, right, environment, info, heap down. All these endpoints reveal certain amount of information. So let's say if environment was accessed, right? So all the environment variables are accessible to a user. And believe me, this is a very common thing. I have come across this like multiple times. And once there was a heap dump that was accessible, and heap dump will give you a heap dump memory file which will have all the sensitive data, if any, like username, password that somebody was logging in, or for that matter anybody was filling let's say a credit card form or entering pi data, right? All of these will be in memory. So heap dump is memory, right? So it is not encrypted there, so everything is in clear text. So similarly, you need to disable all this once you have, the third party framework that you use. It's not related to just Spring Boot, but any framework, any library, or any third party product like a database. So default things should always be disabled. So this is some of the prevention that we just talked about, right? You need to have a hardening process which is across the development, QA, production environment, right? A repeatable hardening process makes it fast and easy to deploy, and it makes sure that all your development, QA, and production environment are same. So also, a minimalist approach for a platform is good, right? Make sure that unnecessary features or components or documentations, right, they are not included as part of the deployment. They should be removed before deploying it to production. Because let's say there is a component which you do not use, and it's still there in the production, and over time, right, you're not even using it, and let's say that particular component has some vulnerability over time, right? Somebody has found, considering you're not using it, you will not be taking care of it, right? So if somebody can exploit that, your application will be compromised. So that's the importance of not using something that you don't require, right? Just disable or remove that part of code and use whatever is required. And also leverage segmented application architecture, right? Because it provides effective and secure separation between different components with segmentation, containerization, right, between different environments. Meaning that, let's say, that particular insecurely configured element is compromised, because there is segmentation. Now segmentation means network segmentation, probably, wherein one part of the component cannot access other. So depending on how your infrastructure is configured, you need to segment. So also continuously monitor your production applications for security misconfiguration. There are various tools that are available, and you can use them to identify, and also it will help you to patch them quickly. So with that, we finish security misconfiguration. We'll move to a vulnerable and outdated components. So this was previously known as vulnerable. This was also part of previous 2017. The name has just changed. So what is vulnerable and outdated component, right? So like we were talking earlier, security misconfiguration, right? It was related to third-party libraries and framework that you're using. Now here, like the name suggests, right? All the modern distributed web applications that we have today often incorporate open source components, such as different libraries and frameworks. So any component with a known vulnerability, right, becomes a liability, right? It's a weak link that can actually compromise and impact the security of the entire application, right? So let's say today you are trying to build an application. So you're not going to build everything, right? So you are going to focus on your features that you're trying to build for your organization, right? So you're going to use Apache web server, probably a database, right? So because you're using this, it becomes an integral part of your application, and you have to maintain that. So when we say maintain, it's not the new features that they update, but also the security part of it, right? So so if you're, so I would say you are likely vulnerable to this particular category if you do not know the version of all the components you use, both the client side and the server side technologies that you use. Okay. I mean, this includes components you directly use as well as nested dependencies, meaning that, for example, you are using library one or framework one, right? But that library or framework is also developed by some other developer, right? They are going to use some other dependency or library in turn, right? So that will also be pushed as part of their code, and you will be installing that, right? So you need to also take care of such nested dependencies. So you are also vulnerable if a software is vulnerable and also unsupported or out of date. What this means is there is a particular framework that you're using, and the vendor has stopped the support for that, right? For example, Microsoft, there is no more XP updates they give, right? So if you're using that, you're definitely vulnerable. Okay, so you have to either move to a different alternative for that particular framework that will help you. And another thing is, your organization also needs to scan for vulnerabilities. When what I mean by scanning is, there are different things like web application scanning, then there is infrastructure scanning, there is container scanning. So when I talk about scan, there are different tools that are available. There are free open source tools as well, also commercial tools, which will help you to identify this vulnerabilities. Now how will they know that, right? What vulnerabilities are available? So they tap into some kind of feeds, like intelligence, like as and when there are different vulnerabilities released for these particular components, right? So they will update their signatures, okay, to identify this vulnerability. Let's say I'm running a piece of code, my code is scanned by a tool that's called as dependency checker. Okay, it checks for all the third party code that is integrated, and it looks at the version, and it has a database, and it checks against that database to see if there is a vulnerability. Okay, you're also vulnerable if you do not subscribe to security bulletins like this thing, right? It is mostly the patch management team that does. Also, if you're vulnerable, if you're not updating frequently, like ideally organization tend, and they have a time period, like for some kind of vulnerabilities they take um, say a month or quarterly updates, patch management does, right? So that becomes a window of opportunity for bad actors if they identify this. Okay, and depending on the severity of the vulnerabilities, also team prioritize their different fixes. Uh, a, a very good example here would be Log4j. Okay, so Log4j is a popular logging utility, and that is by default shipped with Apache. Okay, and not just that, but everywhere. I think anywhere if you're using Java right today, probably that is one utility that is definitely there. So if you have heard about this, then definitely, because it was like priority one. I think December, probably second, third week, there was a storm in um, internet because of this. Like all the top companies, anybody and everyone were vulnerable, and it was so serious. Like it had a rating 10 out of 10, because it was very easy to exploit. And by exploit, I mean I just have to send or make a request to a server. That's it. Like like just typing google.com, and I put my payload as part of the request header, and it'll kind of do the remote code execution on the server. So yeah, so I think so that is vulnerable and outdated component. Just to give an example, right? So I think in 2018 or 17 or 18, probably there was a popular vulnerability similar to this called a struts 2, and the CV was 2017 5638. So which was remote code execution vulnerability that enables the execution of arbitrary code on the server, right? So how did this happen, right? So this breach specifically that I'm talking, right? If you Google for struts 2 vulnerability, you'll see Equifax. So this is an organization, and if you see, right, this happened in mid-May 2000. Attackers were able to exploit this particular vulnerability, and almost 143 million were impacted. And if you see customer name, social security number, birth date, address, all this were exposed. So how did this happen, right? So if you look at the flow here, so the attackers were trying to scam, and the Apache web server was, so just so that right, scanning is very easier. Like there are many tools out there. You just have to give the IP address, and there are different tools which will run scans against your IP address and port number, and it will tell you what services are running. Okay, so this particular service had Apache running struts2. Okay, and struts2 had this CV, that is this particular CV, and they were able to exploit this. Okay, attackers find the vulnerability within the Equifax dispute portal, and once they were here, they got all these documents containing PII information, and using that they also got additional servers and login credentials, using which they infiltrated and also exfiltrated the data, right? So attackers were able to remain hidden while maintaining access. So if you see, this is very sophisticated attack. They found a vulnerability, they got in, right? So once you get in, they also try to stay hidden by not making any noise. We'll talk about this. The ninth one that we'll cover is about logging and monitoring. So right, so they got here, and it extended over 76 days, the data extraction, meaning that they were here, and to avoid any detection, right? So they started extracting slowly from 51 databases, right? So it was very sophisticated attack that they did, but if you see, the entry point was a vulnerable and outdated component. So in future, or even now, right, anywhere, if you're going to either write a piece of code or use different components, you would want to think about this, right? How this is going to, even if you're writing, like, because as a developer, the main focus is always on the user stories. I need to get my code out there with this feature, right? So that's the reason the security team always tries to recommend all these different tools, scanning and patching. So that is vulnerable outdated components, and here are some of the prevention methods that one can use, right? So we discussed all this, but I'll just go through, like, remove unused dependencies and components to reduce the attack surface, right? Like I said, if you're not using anything, just let it go and remove that particular part, right? And maintain your own inventory, meaning that only obtain components from official source, right? So do not download from any unknown source. Like if you're downloading Apache or Oracle, Java, right? So go to their own official website and then download it, and do not download, because you don't know what other people might have compiled in it and might ship that with you, any malware or anything, right? So for any third party library, right? So it's best to also use signature. It will make sure that the integrity of that particular software is intact, and make sure that you keep every software that you use up to date, meaning that if there is a vulnerability out there and the vendor has released a patch, don't wait like too long to, to update that. Try to update as and when you have uh, a possible time, right? Also use trusted channels to download your packages. So similarly, continuously monitor. This is for mostly the security team, I would say. They would have subscription to certain. This is, I think, this is free, but there are also commercial organization which give you intelligence on different components and vulnerabilities, right? So one can, but because once one scans, right, so you can easily identify these vulnerabilities and help you to get them fixed. So this is vulnerability, um, vulnerable and outdated components. So moving on to identification and authentication failures. Okay, so this is the seventh one. So this was also part of 2017, and if you look at it, right, so like the name suggests, this is something to do with authentication. Okay, so confirming the user's identity, authentication, and session management is a critical to protect against authentication related attacks, right? So there may be an authentication weakness if the application permits, automated attacks such as credential stuffing, right? Where the where the attacker already has a list of valid username and passwords. So we'll talk more about credential stuffing in a bit, but also brute forcing or automated attacks to guess passwords, right? So there is no proper mechanism which would prevent automated attacks like bot protection, rate limiting, right? So that will impact the users if they have set a very easy password or weak password for that matter, right? Also, it's important that you have like a very good password recovery mechanism, right? So if it is broken, somebody else can, I mean, that if there is a flaw, right, somebody else can generate the password reset code. And it depends on how one implements password reset. Like for example, if the password reset, if you're on a password page, you need to enter your email address, right? So in the request, you will enter your email, right? So if I generate this email, and if the code somehow can be um, guessed, right? If there is a pattern to that, somebody can try that and break the password reset flow. Also, permitting default or weak known passwords is a bad thing. So default passwords are for all the third party um, components, or so third party products that you use. uh, Also, it is very important that you invalidate the session after logout or password update, or invalidate, I mean, that is if there is no activity, right? Session timeout is important. Now all this depends on how critical your app is. Like for certain like social media apps, like today you log in and you just, there is no session timeout there, right? But for banking app, if you see, there is session timeout maybe like 1 minute, less than 1 minute, right? So you will be logged out of the app. So it depends on which domain you are. Also, yeah, so using plain text, encrypted or weakly hashed password data stores. So again, like connecting back to earlier cryptographic failures, right? So you need to use a stronger or more known algorithms. And if you're not using that, so there will be identification authentication failures. So yeah, so again, if you are using session, right, that shouldn't be in URL, like session token, right? Once you log in, you'll get a session ID. The reason that you don't want it to be in the URL or query string is that all this URL, right, they pass through a lot of proxies or your ISPs and web servers, and that will also be part of web server logs. So anyone who has access to these logs, right, they will be able to use that session if required. So it's a bad practice. So do not use it as part of your query string. So just to give you, right, so this is the top 20 most common password in 2021. So if you see here, right, 1234 query password, such simple passwords, and they'll take less than few seconds to be cracked, right? And earlier I said, right, credential stuffing. So what does it mean? Credential stuffing is like, a bad actor. Okay, like let's say earlier we saw a data breach, right? The Marriott and Equifax. So credentials, when stolen, right, with username and password, are sold in dark web, and anyone who wants can buy them. And if a bad actor really wants, right, or probably state-sponsored cyber attacks, right, all these people, they buy this. And the catch is, once they buy it, what they do is they use that against all other applications. Like for instance, right, let's say user A credential has been compromised, part of a data breach, and this particular attacker buys like millions of data that is breached, and that particular person is also part of that. Now if that person has used that same password for other applications as well, like for example LinkedIn, Twitter, Facebook, Google, right? So all these are compromised, because what this guy is going to do, he's going to use all that credentials that he found against all this. And by default, he'll not do it directly, he'll use a botnet for that. Okay, he'll use a botnet, and that is to avoid any form of rate limiting, right? So there are methods one can do that, and I think this is a very bad practice. So I would say take a moment and think about what your passwords are. If they are weak, you would need to change them, one. And if you're using same password against all the other applications that you have access to, you would want to change that, right? So, and there is also another site actually. It's Have I Been Pawned? Okay, just note that Have I Been Pawned is a site. You can go there and just check your email address. It will tell you if that is part of any of the data breaches. So if you have, check that, and if it is breached, you would want to change your password. So that is authentic identification and authentication. So how would one go about fixing this, right? So what are some of the things that one can consider? So wherever possible, implement multi-factor authentication to prevent automated credential stuffing, brute force, or stolen credential reuse, right? So having multi-factor will avoid the credential stuffing issue. Even if they, you know, try to credential stuff, they would still need the other factor, either the OTP or any form of the token, uh, right? So do not ship or deploy with any default credentials, particularly for admin users, right? If you are bringing in a product, like for instance, let's say Apache, it's a simple example, or MongoDB, right? So if there are default password, you need to change that, okay? Or if you are part of a team which builds such products, like or any product, do not push the code to the production with default or weak passwords. And a good idea is, like any product that you bring, right? First time when you log in, right, you should be asked with default credentials, right? You should be asked to change the credentials. That way, the default credential problem will be solved by itself, right? Also enforce strong password policy, right? This is very important. Everybody would want to set a simple password because it's difficult to remember across so many applications, right? But it's very important to enforce a strong password policy. Also rate limit the critical endpoints like login, password, right? And what you can also try to do is, you can delay the, if there is a failed attempt, right, you can delay the next attempt that one can do. So even like for banks and all today, right, if there are a couple of failed attempts, they'll lock you out for that day unless you reset your password. Only next day you can probably try 5 more attempts. So there is a delay until, if there is a failed attempt, now you should decide, let's say 5 attempts are failed, then there is a delay of say 5 hours so that you can try again, right? So this is going to stop the automated attacks, okay? But you should be very careful here not to perform DOS. DOS is denial of service, okay? And also like use server-side secure built-in session manager that kind of generate when a user logs in, right? The session token needs to be very strong or with high entropy, meaning that it shouldn't be predictable, okay? And it shouldn't be transmitted like we discussed in the URL. So also get your application pen tested. So this is for anyone who is interested in getting into cybersecurity field. There is a separate team, that like offensive team. So we do pen testing as well, and as part of this you run tools and also do manually try to break things. And getting your application tested is a good thing, and believe me, there are some amazing defects that you can find. So there was a bank wherein there were different currencies, and like if you can transfer currency from INR to USD to INR, right? So there was a glitch which would make sure that ideally, let's say 1 USD is transferred and you will get say 75 rupees, right? So it was opposite. If I send 1 rupee, I would get, sorry, if I send 1 rupee, I would get $75. So that was a glitch. So such business logic flaws are also part. So it's very important that you get your application pen test. So some of the like, I think this is what Kibik already covered, right? Credential stuffing, list of known passwords, and most authentication attack occur due to stolen or compromised credentials. So this is again, you need to make sure that your sessions are timed out. If you log out or if you change your password, right? Even if you change your password, the earlier sessions that somebody might have been logged in should be invalidated. Like, so like for instance, for some reason you feel that somebody has logged in, so you go and change your password, right? But what about the old session? If somebody had logged in, even that should be invalidated. So that is mm, so that is the software data identification and authorization failures. So now we'll talk about software and data integrity failures. This is a new topic that has been added as part of this OWASP Top 10. Okay, so like the name suggests, this issue is related to the integrity of a particular software and data, right? So yeah, so this particular software and data integrity failure relates to code and infrastructure that does not protect against the integrity violations. So now first we need to understand what is integrity, right? So let's say integrity is to make sure that there is no tampering done by some third party, right? Third party bad actor. So let's say Alice wants to send Bob a file, okay, a text file. It has some content, okay, and it is not, the content is not necessarily confidential here, but it is very important for Bob to know that Alice sent to me and there was nobody who tampered it in between, okay. So how, so that is integrity. I want to know that it is not tampered, right? So as an example of this is where application relies, like most of the applications that we build today are relying upon different plugins, libraries, modules from untrusted sources or repositories, right? So if you see, right, even earlier two topics that we were talking about, known components with vulnerabilities or outdated components, right? So we were talking about third-party products, libraries, frameworks that we are using, okay? And how do we make sure that whatever we download is not being tampered, right? So let me probably directly jump to an example that will make it more clear. Okay, so yeah, so you should make sure that if your application is downloading from untrusted source repositories or CDNs, right, then you might be susceptible to software and data integrity failures. Or today, right, there is this new thing that is like CI/CD pipelines are available, and auto updates happen as well, right? So like many applications include auto update functionality. Like for example, a router today uh, doesn't check where the firmware comes from, it directly downloads, right? So the auto update functionality is very popular. Like any third party, even for instance um, let's say operating system, right, you can set for on auto update mode for that, right? It'll just check that and auto update. So what can happen here is, if you're not checking where it is downloaded from without sufficient integrity verification, right, um, the attackers could possibly upload their own updates to that particular distributed software patch or update. Okay. So another example is insecure deserialization. Okay, so this is not an example. If your application is insecurely deserializing a serialized object, then it might be an issue. Okay, so serialization is where it's the process of converting probably the complex data structure such as objects and their fields into a flatter format, right? So deserialization is when they reverse that and access the object and process that. So if it is deserialized insecurely, right, so there is an issue. So I'll take an example here. So right, so whatever we discussed here, right, the integrity issue of all the third-party components that you download, right, it's called as supply chain attacks. Okay, so I'll take an example directly. If you have ever heard about solar winds, right, in news, this is it. Okay, so what I'm this service provider is solar winds. Okay, and what solar wind does is it has various products, and one of that is network and infrastructure monitoring. Okay, just to give you some insight, monitoring tools require a certain set of privileges if it is to be installed. Okay, meaning that it needs to probably check the logs or anything. For that, it needs some admin privileges to be installed on your system. So this is this service that they provide. They have multiple products, and Orion is the name of the monitoring tool that was impacted. Okay, so now this particular provider, right, SolarWinds, supplies this particular product to more than 18,000 probably organizations across different countries. And one of the cyber, I would say a group of cyber criminals, and they say that this is a state nation sponsored attack. Okay, meaning that some government probably has funded this, or uh, a group of hackers, they found a vulnerability here. And when I say vulnerability in their services, maybe they have found different vulnerabilities and changed that to get access to the build, right, where the code is updated for that product, right, in their build pipeline probably, and they inserted their malicious code. And once they had access anyways, right, they also kind of pushed this particular piece of code, and any organization that were consuming that particular tool, right, that is Orion IT, as part of their monitoring, we're also consuming this particular update. And with that, you see, this malicious code is is consumed by all the different organizations. And what this piece of code did was, it was sending and getting a lot of data. So one of the compromised organization was called as FireEye. It's a cyber security company itself, and they are known for red teaming activities. Right, they do a lot of penetration testing, then malware analysis, and if you think about this compromise, right, they had some proprietary tools that they used to as part of their malware analysis, pen testing activities, right? Mm, they were all exposed. I wouldn't say exposed, they kind of got stolen by these cyber criminals, right? And it was already too late, and this patch had already gone out there, and 18,000 organizations were consuming. Out of that, I think some were government agencies as well. Okay, so those tools were very important for FireEye. And not just that, considering it is already out there, somebody else could attack other organizations. So what FireEye did was they made it open source. So if you go to FireEye, right, you'll find all those tools there now. So how do we prevent software data integrity failure, right? So like I said, you, in order to check the integrity, use digital signatures. Okay, and also make sure that you are downloading from trusted repositories. Also use some tool like OWASP dependency check and Cyclone DX. Like what these do is they'll check, they'll have database checks of already known softwares and their vulnerabilities, and they'll scan the code and they'll let you know, and you can fix them. Also minimize the chance that the malicious code or configuration could be introduced into your software pipeline. So meaning that you need to protect your CI/CD pipeline, continuous integration and continuous delivery, right? So today everybody wants to push their code very fast and very quickly out to production. So you need to make sure it is segmented, it is properly configured, authentication, multi-factor authentication, because that is where one can get in and push that code to anyone who is consuming. It's like you're using Facebook, right? So if somebody had got into Facebook, say Android app, and sent in a malicious code, and you have updated your app, right? So all your data would be compromised. So this is called a supply chain attack. So now moving on to security and logging and monitoring failures. So earlier we were talking about logging failed attempts, logging some, if some user is being trying to log in for a particular username and there is a failed attempt, right? So you need to log those. So security logging and monitoring failures occur if you're not logging in certain critical events like login, failed attempts, or any high value transactions, right? Also, if your logs are not stored, or if they're stored only locally and there is no backup taken of that, because if the app crashes, right, so your all the logs will go away and there will be no way to identify what happened if some bad actor did something, right? So to do some forensics. Also, you need to protect your logs, because if anybody has gotten into your system, they can you know um, clear their digital footprint by clearing the logs, right? So similarly, vague or improper logs which do not help the monitoring systems. um, just to give you some insight, right, what does monitoring mean, right? All the organizations will have monitoring tools, okay, and these monitoring tools will be integrated with your application, and they consume all the logs like system logs, web server logs, and any other logs that you have, right? So that will be consumed by them, and they have intelligence to look at these logs and look for particular events, and depending on that, right, you need to tune your monitoring tool, and it will generate triggers or alerts. And this particular monitoring tool is managed by a team called as incident response managed team. So it's a department in your cybersecurity team. They are responsible to look at this and see if it's a false positive, if it's really critical, if somebody is trying to attack, how do they manage it, and what's the next step and action that needs to be taken. Okay, so if you look here, right, we'll take an example. Okay, so this is a popular example. Just look for mage card. Okay, mage card is a group. Okay, and what they do is they do similar stuff like we saw like software data and integrity, like supply chain attack, right? So ideally what they do is they compromise any third party libraries that a particular application is using. Okay, so if you see here, a major European airline suffered a GDPR reportable breach. What does it mean, right? So it was British Airways. Okay, just look for British Airways mage card. You'll get the details. But I'll just walk through you. So British Airways, right, where on their online website, wherever they entered credit card details or sensitive data, right, that particular form, right, uh, behind the scenes there was a JavaScript, I think that was the third party library they were using. Okay, and this mage card is the name given to this attacker group of hackers. So they were able to compromise that particular third party library repository. Okay, and what they did was they injected a simple JavaScript along with that. Okay, and what that JavaScript would do is, you see the third party library is getting loaded as part of that form where the credit card sensitive data is collected by that particular app. That is, here it is the airlines. Okay, and what the JavaScript was doing is it was just making sure that all these fields it was reading and sending it to a separate server. Okay, so if you see here, right, so the attacker can compromises and injects the malicious script. How did it inject? That is because it was part of that library, and the malicious script is injected into the JavaScript library used in the front end of the. Here we are just giving an example of hotel. So this is the front end where users consume this, right? So behind the scenes there is this library, compromised library, which is reading all these fields, and then it is sending all the data. Okay, the script loads because the server is accessing that particular page, right? It is skimming that and sending all the information to the attacker, and attacker receives the entire data. And this is very much prevalent, and one of the important thing is that it's very difficult to monitor when this happened then, right? uh, there was no awareness, but today there are many solutions. Hence it is very important that you log and monitor such things. So what could have happened is, if one would have seen that from their site, right? So there are other monitoring tools that are available. Like they also have JavaScript that can be loaded as part of this particular form. Okay, so when you inject that monitoring SDK or JavaScript here, it will monitor the entire DOM model. Okay, and if in this case, right, the data is being sent to third-party server, so it will make sure that it will identify and report it to the tool. That way we'll get an alert that, hey, somebody is sending data to this third-party server, like this might be attacker.com. Okay, this is not belonging to this particular organization, so you need to take a look, right? So this is how logging and monitoring failures, if not implemented, can impact. And there are various tools you need to make sure and consider when you're developing any of the application, how and what data that you need to log. Also make sure that logging doesn't mean that you log sensitive data. Like, if you're entering credentials, don't log that as part of, that's another issue. Sensitive data failure or cryptographic failures. You shouldn't be logging all sensitive data. There is a different. Okay. So yeah, so we were just talking, right? Ensure all login access control fail attempts are logged, right? Ensure that log is generated in proper format so that this can be consumed by all these log management solutions, right? They need to make sense, right? Only then they can generate the alerts. Also, the team should establish a effective monitoring and alerting such that suspicious activities are detected and responded quickly. Also, there can be some kind of purple team activities that can be done, right? A red team and a blue team, they do an activity called as purple team activity. When red team tries to attack and blue team is that incident monitoring team, and they see that proper alerts are generated as part of this activity and everything is working as intended. And if something is not working, right, so they try to tune it and make sure that such alerts are generated. So this is very this is a separate topic actually, and this is pretty much it. So we'll move on to server-side request forgery. And server-side request forgery, right? So it's a particular type of vulnerability wherein a web application is fetching a remote resource without validating the user supplied URL, meaning that a attacker is inducing, okay, and telling the web server to fetch something. Okay, it is giving a URL and telling on behalf of me, please do this. Okay, so whenever web application is fetching a resource, so it's like this. So there is an attacker, there is a website, okay, and ideally I would send, this is a post request, and as part of that request, right, there is this another URL that I would need. That application is designed in such a way that there is another URL. If I'm trying to check some stock for a product, right, so it will go here stock and check for that, right? But what if I don't enter this URL? Okay, what if I don't enter this URL? And this is how the website is. Website has access to another server and maybe some set of servers here in the same subnet, if there is, right, in the same network, right? So if there are any server, if this website may be able to talk to this, or maybe website also has access to internet. Okay, so instead of this, if I add this, right, as a bad actor, so that will give, I mean, what will happen is this particular request will go to this website, but this website will make a request to this particular internal server. Okay, now as an example, we have just given an internal server. What we could also do is ask the server to fetch something else from the internet, right? So we'll talk about the impact of this, but it'll give me the response here. Okay, so I'll take an example, very good example, and we'll conclude the session with that. But what can happen is port scan internal servers, meaning that one can easily use this technique to scan internal network here. Right, because this server is acting, as I'm saying, as a bad actor. So we can do that. There's a way you can run scans and get a lot of information of how the subnet is, what servers are available, what services are running, and then take your next step to compromise that particular organization network. Okay, so another thing is sensitive data exposure. Like, we saw that we used a protocol here, HTTP, but it is not only restricted to that protocol, you can use FTP and any other protocol that might be used here. So this is more of trial and error method, and there are tools that will automate this for you, and it is easy. Okay, so once you use that, right, local file system can be enumerated and any sensitive data can be accessed. So if you see here, this etc password is a system file, right, so which contains some sensitive data, and like similarly any file, if you want to access, you can try that. Also, this is more the reason this particular vulnerability is popular is because today because of cloud, right? So there is something called as metadata endpoint. Okay, so all this cloud instances, right, EC2 instance, right, will have this particular metadata endpoint, meaning that this is like how you have local host, right, 127.0.0.1. this is constant, like any instance you set up, right, this is constant, it's going to give you metadata for that, and we'll talk about it in shortly. But this is the impact of software side request, server side request forgery. Okay, it's SSRF, and this is a very popular Capital One breach, and 140,000 social security numbers, 1 million Canadian social insurance and bank account numbers and whatnot were part of this. Okay, and it was really interesting, and we'll take this example, right, and we'll recreate this scenario. Okay, so I'll be using this particular application called as Contra, and they have very good way of showing or recreating some of the vulnerability. So this is a particular bank scenario here. Okay, so it will be called as capital 10 for now. Okay, so I'm just going to go with the flow, and it's very interesting to see how it happened. Okay, so if you see here, this is the Capital Bank, and I'm logging as a user. Okay, let me say Bob is the bad actor here. Okay, and tada, you are logged in. Okay, what happened? Just a second. Sorry, it just refreshed. Yeah, I just logged in now. Okay, now the bank has different features, like more account services. Go there, and they have something called as change card image, meaning that this is the credit card, and you can change the image of that, how it comes to you. Okay, that's the feature, and you can put in an image. Okay, now if you see, please concentrate here. This is the URL right now. Okay, and when I upload and preview, right, I upload this image, and then I'll see how the card looks with that image. Okay, and this is how it looks, right? So if you see the URL here now, there is a parameter called as URL, and it is kind of fetching something from this particular bucket, S3 bucket. Okay, and this is the file and image that has been loaded. Now let's move on next, right? So if you see, this is the So now what we'll try is, this is a S3 bucket, right? But what we'll try is, we'll try to see if we can fetch anything else. Okay, so let's change this to this particular endpoint, and you see that this particular image was fetched from this particular site. That is, it was able to. So what happened now, if we go back here, right, so we were talking, right, so the request went here, and we asked the server to do either access internal data or go out and fetch that particular image, and it did that. Okay, so now moving on, let's take a look what is happening behind the scenes. Okay, so let's go and analyze the code. So if you see here, there is a document preview method is used for rendering that particular uploaded image, and if you see, it is taking the URL parameter and assigning to a query string here. Okay, so query string, and then if you look, the query string is then passed and to a storage service load method, which is responsible for downloading preview image from the S3 bucket. Okay, so yeah, and then finally that request is made, and then image is fetched with this particular HTTP GET call. Now let's move on and see what we can do next. And this is the point we were discussing earlier. You see the metadata, right? The metadata is going to give you a lot of information from that particular server. And let's just go and ask for this particular metadata and see if it works or not, right? So when we do that, it gives us all the metadata that is actually out there. Okay. And as next part, see, this is a pen testing methodology and technique that one uses to do that. I know this, so I'm just telling you. So instead of now just metadata, we'll ask for IAM credentials. So if you know identity access management, right, that is IAM. So IAM is a place where all your credentials will be stored, your AWS keys, secrets, right? All these tokens will be stored, which using which you can access the buckets and all other stuff for that particular web server. Okay, so now we'll access that, and you'll see that we actually got back that particular, ISRM WAF role. This actually happened, and this is how one was able to compromise. Okay, so now we'll go ahead and access that ISRM WAF role here. Okay, and if you see, it gave us the secret key and access ID, right? If you see access ID and secret key. So now what one can do with this, it's a gold mine, right? So you download the AWS SDK, configure these keys, and try to download the S3 bucket that is available there. S3 bucket, if they have stored something there, right, sensitive data, you can get it. And this is how exactly it happened. So if you look at this, right, so if you see here, they have already configured the SDK, AWS SDK, and they have exported the access ID, key ID and access key that was found from the previous SSRF attack, and they are going to just list the S3 buckets, right? So this is how exactly the lady who performed this attack, right? She was arrested, and just read upon that and you will come to know that it was crazy, and like military had come, and there are a lot of breach that happened here because of this particular vulnerability. And when you look at it now, right, it is pretty easy. And that time I think it was not that known vulnerability, and that's the reason, because of the cloud providers today, right? So it has gained popularity, and many people have reported this at various places. So that is it. And how can you prevent this, right? That we need to talk, right? So one thing would be, like we saw here, right? You don't want to put everything at one place. So if your website doesn't need access to other stuff, you need to segregate and segment that, so that one cannot access even if there is an SSRF, right? So that would be it. Segmenting remote resources and functionality in a separate network to reduce the impact if an XSRF is available there. Also, you need to sanitize and validate all the client supplied input data, meaning that the URL that was entered, right? You should have a allow list, say only these domains are allowed. Like for example, if it was validated that, stock.internetendpoint.net, only this is allowed. Nobody could add anything else and tamper with this, right? So similarly, do not send back raw responses to client, right? So filter that, see what is there, and do not send everything raw. Also, it's a good idea to redirect any HTTP redirection internally. That can be set up. Also, by default, make sure that everything is denied, like firewall policies, the outgoing policies that are configured for that particular web server, right? Depending on the need of the particular application, you need to set the rules and block, but only allow essential internet traffic. So that would be the prevention for SSRF. And I think we are out of time, 10 minutes. So I think I would close. I know that it was a long session, there are a lot of to cover. I didn't get a chance to ask questions, but if you have any questions, please do ask right now.
Thank you, Sai. It was a wonderful talk. OWASP Top 10 is actually it's a very huge topic.
Yeah.
Yeah. I think Mr. Vijay has few questions. I have already allowed all the participants. If they want, they can unmute themselves and ask questions.
Okay.
Vijayan,
Okay,
sir, you can You can unmute yourself.
I'm just reading, Vijayan. If
Yeah,
you
yeah.
want to talk, you can go ahead. I'm just reading the question. Do we have? Okay, so looking at Vijayan, right? Questions like first question: do we have any website or tool where we can understand real time or practical exposure on OWASP Top 10? Okay, 100%. Yes, there is one. Like for instance, this is OWASP Juice Shop. Okay, you can download this from OWASP website. OWASP, just Google for OWASP. Let me just do that. OWASP. Okay, and if you go here, right? So okay, OWASP has many projects. Okay, if you go to project, right, I think when they started with OWASP Top 10, but they have many projects now. So for you to get started, right, I would suggest OWASP Web Goat is a good platform, and the second is Juice Shop. Okay, these two are deliberately vulnerable apps out there to learn web application security. Apart from this, there are many vulnerable apps. There is something called as damn vulnerable web application. Okay, and there are many actually out there. I think Budget is another store. So they are fine. And I think you also asked if this is only applicable to web applications, right? All this OWASP Top 10. Yes, this is application applicable to OWASP Top 10 for the web application, but OWASP also has something called as mobile security. Okay, so they have mobile top 10 as well. Okay, so how the data is stored on device and how the intents activities that are used as part of this native apps, right? So how you can abuse that in, let's say for example, third party mobile is installed, right? A malicious app, can that invoke something on your app? That can be done, and they have top 10 for that as well. So it's a good thing. That is another one. Another question was what is the major difference between 07 and 1? Broken access control and identification authentication failures. Okay, so the main difference, right? Access control and authentication, that is the main difference. So the broken access control talks more about authorization, identification and authentication, right? That talks about authentication, like how one can compromise. So if you look at the slide, right, we talk more about default passwords and brute forcing credential stuffing, right? So it's more on authentication. Authentication is who you are. The application needs to identify who you are. Authorization is after authentication, right? What you can do, like for example, if there's a portal, right? Authentication, if I compromise my manager's credential or say a professor's credential for that matter, right, I will be able to access more stuff on that particular portal, right? So that is authorization depending on the kind of role that I have, right? But authentication is still the credential part, right? How we can secure that, how we can make sure that nobody is able to brute for my credentials. And if my credentials, I'm using common credentials across different apps, that's a bad practice, right? But in access control, that is not like the main concern over there. The main concern is like whatever data is stored, right? We saw about insecure direct object reference, right? There was no authorization check saying that that particular account, when requested by the attacker, right, was asked, I mean, it belonged to that particular user that is logged in. So that is what authentication part deals with, who you are. Authorization talks about what you can access or what you can do, what access do you have to the data or resources. Okay.
And I hope
Okay.
you answered third question also, Sai, related to
Okay.
mobile applications.
Yeah.
Thank you. I hope you answered all my questions. Thank
Okay.
you so
All
much,
right.
Sai. Thank you. Yeah.
Okay. So any other questions?
Overall, it's good, Sai. Good job. Thank you.
Okay. All right. Thank you. Any other questions, anyone?
I just have few comments because I also follow OWASP Foundation
Okay,
closely.
sure.
Yeah.
Go ahead.
So those who are in, those who have attended this session, you can think of starting OWASP chapter at your city, and OWASP Foundation supports that. We have OWASP Belgavi chapter, and you have very good advantages there. Say for example, you can apply for funding for your projects. If you are thinking of any open source projects related to OWASP goals, then definitely yes, you can apply and they will fund. They will also provide funding for conferences, so you can explore uh, the different opportunities available in OWASP Foundation.
Yeah. And just to add, right, so whatever we discussed today is just the scratch, like we just scratch the surface. So each of these vulnerabilities that we discussed, right, if you go in deep how to test particular vulnerability, there are different tools that you can use, and particular techniques that you can use. So, and when you move from web application testing, right, so there is offensive security that comes into like red teaming activities, like active directory hacking, active directory, or for that matter like all this container Kubernetes. There are different techniques. So I mean this is just a scratch. So anybody who's interested, right, OWASP is a great place to start. I mean I myself started here 10 years ago, and that's the reason I chose this, because anybody who's interested, you have to go and take a look at different projects there. You can start with OWASP Top 10, then move on to different tools they have. And like I said, this OWASP juice shop, right, so this is a local Docker that I've installed. You just have to run 4 commands and it will be up and running. Okay. And this is vulnerable, and also it has a companion guide. Just look for OWASP juice shop companion guide. It will guide you, kind of provide you hints where you should do what. It's pretty interesting. So that would be it. I would like to thank Gajendra Deshpande sir, Padma ma'am, and all the coordinators as part of the winter school. Thank you very much. And also thanks to KLS GIT for giving us the opportunity to share some knowledge. It was really nice. Thank you.
Yeah, thank you, Sai, for delivering a very insightful and much needed talk